Hi, good morning, everyone. My name is Fabio, and my colleague Ani, and we have two colleagues here in the audience that we'll introduce later that help us with this work. So what we're going to talk today is on, I want to give you a quick overview of what Clover is and what it's doing, and then we're going to delve into the use case we are covering with our containerization of cost, which is our monolith, stand for Clover operating system, and how then we use it for with Rainbow deployment. We will go through a little demo that Ani will drive, and then we will go over the conclusion and next steps of this talk. So just to have a sense, who here is familiar with Clover, heard about Clover, seen Clover devices? Okay. So let me go a little bit on detail what Clover is. Clover is what is called an integrated or fully integrated point of sale. Traditional point of sale will just do the payment for you, take a card and you swipe it, tap it, and it will process the payment. A fully integrated payment system does way more than that. Has a plethora of applications that you can rely on, as a backend, services that will show all the transactions, what you are doing. And so it can do things like manage inventory, manage your employees, deal with loyalty points and all this kind of stuff. So Clover has been successful in selling these devices. This is the new way, basically, payments is managed, because through that and integration with third party, you get to run the business in a simpler way than you would with the traditional systems. So what is the use case for us? So what we've done with our monolith, we have a monolith that was deployed a long time ago. So we containerized it, and we looked at how we can improve our day two operations with it. So one of the things we've done, we start to look at Rainbow deployment. So you must be familiar with blue deployment. That's traditional deployment. Rainbow is nothing more than expanding the number of colors that you can use, right? So that's why it's called Rainbow. Why you want more than two? Well, think about it this way, right? You may have customers that are very sensitive to change. They do not want to have new versions, new releases, because the kind of features they're using, they're fine. They're very reluctant to get risk. And so those will be running on what will be your last known, version, or what is long-term support version, and they will be stuck to work with that until we will deem a new version being worthy to become the next release. And then you have the customers that are going to move into the green deployment, which is your next major release, where you want to move the customer to, because it's where you improve the quality of the software, add new features, and so on and so forth. And then there are other two cases where you can bring multiple colors. One is that you can have experimental features where you want to route certain customers that are beneficial from it. For instance, we have real cases like multi-location. Majority of our customers have a single location, but some of them have multiple stores, so they want to use multi-location. So that could be a typical use case of a feature that benefits only a subset of the population and not the entire one. And then the other one we will demo is, what if something goes wrong during the release of your next major one, and you want to introduce a fix. So you want to test that the fix actually works in production, and so you can have an hotfix release that runs in parallel with the others. So what are we demoing? Let's start with the way we build infrastructure. So one of the benefits of Nomad is that we build infrastructure exactly as we built it before. So we have all these virtual machines that have the Nomad agents in it, and they're part of the cluster, and those are built following our Terraform build that will be exactly the same or very, very similar to what we've done when we build the virtual machines. And then on top of that, we deploy our workloads, our cost workloads. What we've done also, on top of this, we have leveraged an open source component called OAM, Open Application Model. I'm not going to go too much in detail. I'm just going to give you a little idea of what it is. You can find it is is a CNCF project. It's om.dev. And the reason we introduced that is because OAM simplified the deployment file, and it becomes very, very simple for release management to identify and express the deployment. The OAM file is submitted to Git, so we do a GitOps operation, then there is a GitHub action, and that is transformed into ACL, applied to Nomad, and we deploy the workloads. So if you look at the way OAM is defined on the left, or your right, basically is composed by two parts, the components part and the traits part. The component part is really linked to the application definition. So when you translate that into ACL, it will be comprised of task groups and tasks, whereas the traits defines more of the characteristics of the deployment. So you can see the benefit here is that I can let people define most of the component part and less of the traits. So I can control the way the deployment is executed and fine-tune it without having the developers to care about. So it brings a level of abstraction that makes deployment consistent, validated, and controlled by the platform engineering team. So the demo will be relatively simple. We'll go quickly around it. At the beginning, we will have all the traffic running on V1. Everybody's happy. Everybody's running on the blue, which is the existing version. Then we're going to start to migrate customers to the second version of the workload with certain percentages. But what happened is that we start to see that some customers are puzzled by features that are not expected to be working as they were thinking or planning to. And so for that reason, we're going to introduce a new version that fixes that. And so we will pin only those customers that see the problem into the new version. So then they can validate that our hotfix is truly working and has been addressing their needs. And when the version 2.1 has been considered valid and good for some time, then even the customers that were reluctant to move, we can tell them, hey, the version is stable now, we've been tested for a while, please move over, and everybody will be going back to the latest version, and then the cycle can start again. Okay? So with that, it's demo time.
All right. So we'll start the demo from the Nomad UI. Here in the jobs view, we have the three cause instances, the one that starts with F48, 4CB, and 875. And then we have a load balancer to distribute the traffic among these cause instances. And then in the topology view, we can see the three classes of Nomad clients, the blue Nomad clients running the version cause 4CB, the green Nomad clients running the version cause 875, and the red Nomad clients running the version cause F48. So with these in place on Nomad, let's take a look at the load balancer configuration that we have right now. So in this load balancer configuration, we define the basic routing as the cause default. That's the default upstream. So in the upstream, we have the three IPs corresponding to the blue Nomad clients, and there is no wait at the moment. So it's 100% of the traffic should be going to the cause default, which is the cause blue client. So this can be represented on a Prometheus dashboard. So let's take a quick look at the Prometheus dashboard. So we are reiterating the versions of cause and the corresponding colors. And at the bottom, at the bottom panel, we have representation to show the 100% of the traffic is going to the blue clients. And all of this is represented in the Nomad spec file, similar to what Fabio explained, right? And in here, under the policies, we have for the cause application that 100% of the traffic needs to be going to cause 4CB. So that's the only one under the versions section now. And that corresponds to the blue clients. So now let's go ahead and make a change to the traffic pattern. So we create a PR, and in the PR, we are going to say the existing cause 4CB is going to get a weightage of just 50, and we're going to split the other half of the traffic with the green clients by providing the same weight value. Right? In addition to that, we are also going to pin a customer by the xClient ID request header and match the value of the customer's ID starting with the string BBVD. And if you see this customer's traffic, we are going to pin the customer to cause 4CB, which is the version running on the blue clients. So let's go ahead and merge this change. So we're going to go to the, you all know how PR works. We're going to go to the main and make this change applied, squash and merge. So once this is merged, the GitHub action is going to take over, and it's going to convert the OHM spec file into a Nomad equivalent job spec. And that's going to apply to the load balancer that's running on the Nomad. So the updated Nomad config, the updated load balancer config should look like this, where we have the 3 Nomad blue clients earlier that we had are going to have an associated weight of 50 now. So all 3 nodes are going to get that. All 3 nodes are going to get that. And in addition to that, we have the 3 new IPs corresponding to the green clients, and they also have the same weight values alongside them. In addition, we have the upstream BBVD corresponding to the customer. So for the traffic coming for this customer needs to be sent over to the blue clients. So we have the IPs corresponding to the Nomad blue clients. Notice that we don't have any weight. So all the traffic coming from this customer is going to be sent to the Nomad blue clients. And to tie them all together, we have this map which defines the routing. So if you see the string BBVD, you're going to send it to that specific upstream. And if there is any other sort of traffic, everything else goes to the default, which is the cost default. Right. So that's the place we have defined. And so we are going to declare that map as the new routing policy by giving it to the proxy pass. So with this change, now if you go back to the Prometheus dashboard, we can see that in the Prometheus dashboard, we can see that there is a traffic split between green and blue, the equal split that we would expect. Right? So next, let's test the customer pinning by making some simple REST API calls against the load balancer. So here we are going to pass the customer ID BBVD that we are pinning against the COS v1 GSHA endpoint, which is supposed to just return the COS version running, and against the load balancer address. So if you make this request now, we expect to see the 4CB, which is the version running on the blue clients. And just to make sure that that's right, we're going to reiterate a few times and prove that it's the same value that we're getting. As a last step in this exercise, we are going to pin another customer, CCVD, to the red clients. So the COS F48 is going to get all the traffic from this customer. So the same exercise, we are going to merge this change. And once we do that, it's going to again kick off GitHub action. And that is going to again convert the OHM spec into the Nomad spec. And it's going to apply against the Nomad cluster. So it's just verifying that that's happening there. So once that is applied, we can go back to the load balancer to make sure we have the updated configuration. And in here, everything else should be the same, except that we are going to add a new entry to the map corresponding to this new client, CCVD, and have a corresponding upstream. And in this upstream should just contain the red Nomad client IPs and no weights. So we're going to make the same sort of test, REST API-based test. And we're going to pass the string CCVD, in this time, and against the exact same URL. And if we make this request, we are going to expect to see the F48 version as the response output. And now if we go back to the Prometheus dashboard, retrading. If we go back to the Prometheus dashboard, we should see a sliver of red appear that corresponds to the manual API calls that we made. That should be the end of demo. Thanks.
Okay. Thank you. So you're saying that we were running at a given time, right? 3 versions of it. We didn't roll everybody back to 1 version, but the demo showed that we were running 3 versions of the COS at the same time. So what has been our takeaways here? So first of all, when I challenged the team to containerize our monolith, one of the goals I set for them was, our developers don't have the time to go and work on the monolith and remove all the OS dependencies and make it, slim enough that could run on Kubernetes on a different platform. So what we've done is that through Nomad, and because we could register existing virtual machines into Nomad, it allowed us to basically containerize around the monolith with no code changes from the developers, which for us has been a big win because basically we were running on virtual machines before with all the complexity of day 2 operations. We have Puppet, we updated the OS independently. Now we have a system that allows us to use Packer. We build golden images. We can bring those new images using a immutable infrastructure, as well as we can deploy during the day. We don't have to take a window to upgrade our costs because we can now start to route the traffic slowly, and then as soon as we see issues, we can roll it back, right? And we have every merchant or commerce-related businesses, we typically have a peak over the weekend, and then it tails down during the week, and then it picks up again on Thursday, Friday. So for that reason, we have the ability now to load test the system during the peak and validate that will work. The other thing is that another aspect of our release process has been improved is, you probably have, you remember a blog that was done in the past that was called Kubernetes the Hard Way. And I think if I want to draw a paradigm with this, I think Nomad is actually the easy way, right? Now, we use Kubernetes from the cloud, GKE, AKS, those are managed, the complexity disappears. When you still deploy your own VM, though, Nomad brings a simplicity to it, which is staggering. So the team has been able to take this work and ramp it up with very, very little prior knowledge and very little learning. So the learning curve has been really, really low for us in order to run Nomad. And lastly, now we can also release based on feature flags. So in the past, we had a code base with feature flag, but we will release those into a single instance of the cost. Now, what we could do is we can start to release it into different versions and validate the different features with customers, get feedback, understand how they work, and then combine them into the future release and stuff like that. So, so these are the benefits that we have seen in containerizing the platform and using an orchestrator as Nomad to simplify our management of the releases. What is our next steps? You've seen our infrastructure in the demo and in what we have so far is pretty much static, right? We build the nodes that we need to run the different versions. Those are pre-built, available, and then we deploy on those versions. Of course, this has a lot of infrastructure cost associated with it. At this stage, we are not worried about that because we want to validate that everything works and everything follow the model that we want to bring into production. But moving forward, what we would like to do will be to move into a auto-scaling approach where, based on the load and on the traffic, we can move from a version to the other. And so the idea will be that with the auto-scaling capability, we should be able to start to increase the workload load on the new version directly proportionally to the amount of traffic that we send to it, right? And then depending on our appetite to risk, we could start to remove resources from the blue in this case, or leave it there if we feel that until we reach a certain percentage or a certain level of confidence, we still have the ability to go back to the old version and keep it all alive. So if, during a Saturday night with high traffic, we discover something, we can go back and we still have 100% of capacity on the prior version, so we can definitely sustain the traffic. And so in this model, when the release will increase and the traffic route will increase, Nomad will take care of bringing up the amount of resources that are necessary now to sustain the workload that is shifting from V1 to V2. And then there is another aspect, which is to promote the release. So at a certain point, after we've run it for some time, we did some testing, everything looks good, we should be in a position to say, okay, now we think that this version is stable. We don't need to keep the old version around because the customer has been running happily on that version. Nothing has been reported for a certain amount of weeks. then we would like to send a promotion signal, right, saying, okay, we don't need the old version, and have, Nomad basically not only remove the workload, basically the provision it, but the provision infrastructure that goes with it, since it's an infrastructure that is not needed anymore. So we are looking into these capabilities and see how we can extend our current work with it. Another thing I want to say is that going back to our home definition, what we also have discovered is that simplifying the release process, having a smaller format or a simpler format to consume for our release management and developers has been extremely beneficial. In the traditional VM deployment, we expose a combination of ACL and Puppet, and it's been proven challenging at times for people to understand where to make the change, what changes are needed, and which environment they need to go, and which part of the Puppet they need to change. And so that requires usually a significant amount of review from the release management and other people involved to avoid or prevent mistakes. With a simplification with an abstraction layer like Home, that allowed us to, first of all, pin that file to the particular environment when you want to deploy. So when you make a commit, you can make a commit to a repository that represents an environment, so that there is no risk of making a change that can affect other places. But also, it becomes very, very simple the way you define it, and then we take the abstraction layer and we convert it programmatically into the necessary constructs in ACL. With this, I really want to thank our colleagues, Dilpreet and Sukhvinder. Please stand up, guys. They are part of the core team that help us to make this work possible. And I want to thank you guys for being here. And we will be standing outside if anybody has questions or want to talk to us about our experience. Thank you very much for your time.